The 604 practice number 3. You needed to write an equation to represent the relationship between the step number n and the number of small squares y in each step. So in the previous questions to this, you answered questions about what it would be in step 6 and step 15.
Ms. Medina.
Previous to this question, you would have had to tell me how many squares are in each step. So how many squares are there in step 1? In step 2? In step 3? And then in the previous step had to do like step 4, step 5, step 6. So let's just do at least those so you can see the pattern. And I would highly recommend try to look more so for the pattern within the numbers than like of these squares. But what are we noticing about 1, 4, and 9? What do they have in common? Okay, so how many will I have in step 4? 6, 0.03, 6. Okay, how many would there be in step 5? Class. So what do 1, 4, 9, and 16 all have in common? They are all. It would not be 24. Nice try. Okay, 25. Are we seeing the pattern now? Like, what are all these numbers? Okay, what about in step 6? How many would I have in step 6? Okay, what are you doing each time to decide it to get the numbers? You're adding 2?
Like competing and you have to get out.
Does anyone else know what's going on? Because these are the right numbers for the steps. But what are all these numbers? We're not adding 2. Okay, quadratical. What are quadratics? Like, what's the basic formula for quadratics? Okay, these are all perfect squares. 1 is 1 squared. 4 is 2 squared. 9 is 3 squared. 16 is 4 squared. 25 is 5 squared. Do you see the pattern? So aside from just, I don't know, trying to picture the shape, the pattern that's going on in the shape, the pattern within the numbers is that they're all perfect squares. And really all you had to do was square like the step number. Does that make sense? Do we see it now? So in that case, the only thing that's changing each time is the step number, which they want you to use the letter n. So it'll be n squared equal to the number of small squares, which would be like these numbers. So it equals y. You could write it like this, or you could reverse it and it's still true, but that's what you're putting. Once you figure out the math that's going on, things that are staying constant should be numbers. Things that are changing each time, like the step number is changing each time, should be a variable. And then like the number of small squares each time is changing, that should be a variable too. Make sense now? Okay, other questions from any practice? Unit 6 preferred, since that's the one we're focusing on, but. You got number 9 on this practice? Okay. same practice, if you wanna follow along, or if you'd rather work on like, I don't know, the ones from this week, or work ahead, maybe, or thought I turned in, but otherwise, we're on number 9. So each figure is composed of large and small squares. The side length of the large square is x. And we need to write an expression for the area of the shaded parts. So really great test questions, because it requires you to know quite a few things. Like, how do you find area of a square? Length times width, and what's special about squares? They have all the same side lengths right around it. So you could write it like this, that'll get you the answer, or you could write it, since these are squares, side length square. Both give you the area of the square. And it gave me some information. The side length of the large square is x. So if this is the side length of the large square, and it's a square, that means this must also be my side length for that side. What's my area of the large square? If area is length times width, and my length and width are both x, what's x times x? So that's my area of the large square. But really, we just want like an expression for the area of the shaded part. Almost the whole large square is shaded. I need to account for these non-shaded small squares. Do these small squares add or subtract from the total shaded area? Subtract. And then we have dimensions for the smaller squares. We have dimensions for the smaller squares, they're 1 by 1. So what is the area of the small square? What's 1 times 1? And I have 4 of them. So really I have 4 times 1, which is 4. Let me find the parts that match that. So that is what you're doing. You're using your problem solving skills, a little bit of your exponent rules, knowing that x times x is x squared. And that's it for figure A. Make sense? Now for figure B, these are considered the large squares in figure B. So part of the information is that the side length of the large square is x. So what's my area for the large square in figure B? The area. Maybe use this formula. If the area of a square is side length squared and my side length is x, what's my area of figure B's large squares? I know you guys are in 9th grade, this might be like your first experience with this, but to me, it's like I'm asking you what 1 plus 1 is and no one knows the answer. Like, it's really honestly so easy. What's x times x? X squared, that's it. That's literally it. So remember that. X times x is x squared for the area. That's your exponent rules. When you have x to the first times x to the first, you have the same base, you can just add the exponents. That is it. So remember that, because if you don't, then I don't have faith in the next unit test. But the area of the large square in figure B is x squared, and we have 2 of them. So for figure B, we have 2x squared. And then we have these additional small squares. Do these add or subtract from the total shaded area? So it'll be 2x squared plus, what are the dimensions of the small squares? They're labeled 2 by 2. So what's my area of the small square? What's 2 times 2? So it's 2 squared. So whatever one you put it in, it's the same area. And then we have two of them, so 2 times 4 is 8. So now let me find the expressions that match that one. But that is how you do that. You use your problem solving skills, a little bit of your exponential, nothing crazy. X times X is X. So good on that one? Good on others? Number 8 on this practice. Okay, so this one I had to change the wording because the way it was worded before, there would have been like more than one right answer. The way that I changed the wording now makes it to where there's only one right answer. So it says, at what whole number does 3 times 2 to the x eventually overtake the expression 3x squared plus 2x? You might not see this wording unless you like open a new submission for it. But that's the new wording. That's the one that makes sense. So you have a few options to solve this one. You can make a table. But what it's really asking in that lesson 4 that you should have watched, one of the things that was discussed is like the difference between an exponential and a quadratic, like with how fast that they grow. So I'm gonna graph both so that you could see that. And I actually already did in my other class. So here it is. 3 times 2 to the x, 3x squared plus 2x. And I'm just gonna adjust my window so that you could see it better. We wanna know at what whole number. So I'll start at 0 then on the x, and maybe we'll go to like 10. And we can adjust more if needed. The y-axis, I'll leave how it is. I don't know when exactly it will overtake it. So here's my 2 lines graphed together. My red is my exponential. It starts out where like my whole numbers are higher, but then the quadratic exceeds it like right here. But it's a rule that exponential functions will always eventually exceed your quadratics and your linear. Exponentials always grow the fastest. So let me see where they intersect. Desmos lets me click on it, luckily. So at 4.596 is when the exponential starts being greater. So starts overtaking the quadratic. So what whole number do I need to type into my box? At 4, the quadratic is still higher. So 5. But again, I didn't change the wording until today. So previously it was kind of confusing. But the answer should be 5 for when it overtakes the quadratic. Okay, good on this one? We might have time for one more depending on how long it is. Desire? Number 5 on this practice? Okay. So the bell will ring at 12:27. You guys are welcome to go if I'm not through by that time, or you could stick around and get this answer and explanation. But this is actually not that bad. I think we can finish it. So it says 10x squared grows by blank amounts. So what do you think? Increasing for sure, goes from 10 to 40 to 90 to 160. But by blank growth factors. Remember, factors are things that we multiply. So you would have to find the growth factors for this column. How can I go from 10 to 40 by multiplying? Times 4. Then to find what I need to multiply 40 by to get 90, I'm gonna like do the reverse, and I already did this earlier, so that's why I remember the answer. I get 2.25 is what I need to multiply by. when I do 160 divided by 90, I get like 1.7 repeating. How are these growth factors changing? The growth factors themselves are decreasing. So that's the hard part, I think, on that one. The expression 2 to the x is increasing or decreasing? Or is it exponential or linear?
It's linear.
It's not linear.
Oh, that's hard.
And it doubles or halves. Okay, cool. It does, it does. All right, go to your second hour now.